When you think about cutting-edge battery tech, your mind probably jumps to a slick EV or maybe your smartphone, right? But what about that giant rumbling cement mixer you see at every construction site? Well, it turns out that electrifying one of those is one of the gnarliest engineering challenges around. So let's get into it and find out why. Right off the bat, the difference here is just staggering. On the left, you've got the old school way, a loud, gas-guzzling system that's less than 70% efficient and has to keep the truck's diesel engine running all day long. Now look at the right. The new hybrid solution is over 90% efficient, and this is the kicker, it lets the truck's engine shut off completely while the mixer keeps on turning. This is so much more than an upgrade, it's a complete reimagining of how these things work. So here's the journey we're going to go on. First, we'll lay out the big problems with traditional mixers. Then we'll dive into the hybrid electric solution and the absolute beast of an engineering challenge at its core, the battery box. From there, we'll see how it's built to survive the world's roughest ride, how it passes a crazy gauntlet of global safety tests, and finally, what all of this really means for our cities. Think about any construction site. You know that sound, right? That constant drone of diesel engines. Well, a huge chunk of that noise and pollution comes from the cement mixers, which have to burn fuel and run their main engine just to keep that big drum spinning. It's a massive waste of fuel, and it creates a pretty awful environment for workers and anyone living nearby. Okay, so the solution is this really clever hybrid system. It uses a dedicated high-voltage 400-volt electric platform just for turning the mixer drum. The real genius here is that it completely separates the mixing job from the truck's main engine. The drum basically gets its own power source, and that, right there, changes the entire game. And this diagram really shows you that fundamental shift. On the left, you see the old mechanical setup. It uses something called a power takeoff, or PTO, which basically just siphons power directly from the truck's engine. It's loud, it's clunky, it's inefficient. But on the right, you see the new architecture. A clean, powerful, and quiet electric motor runs the drum, all powered by its own dedicated battery system. This one change is what makes silent engine-off operation possible, solving those core problems of noise and wasted fuel. But here's the thing. To make that beautiful electric system a reality, you need a battery. And for a machine like a cement mixer, you can't just grab one off the shelf. This battery becomes the single most complex, most critical piece of engineering in the entire vehicle. This quote from the report just nails it. The battery isn't just a component, it's the core of the whole system. It's where safety regulations, energy management, and brutal structural demands all smash together into one box. If you fail here, the whole project is a failure. So let's just lay out these hurdles, because they are massive. First, it has to survive an unbelievable amount of vibration from two different sources at once. Next, it has to somehow meet a tangled mess of different safety rules from all over the world. It has to pack a ton of energy into a tiny space, because if that battery ever dies unexpectedly, you've just created a multi-ton block of useless, hardened concrete. And finally, it has to do all of that reliably every single day for a 10-year commercial lifespan. No big deal, right? So let's tackle that first problem, which is maybe the most unique challenge for a cement mixer, the vibration. We're talking about a level of punishment that makes standard automotive tests look like a gentle Sunday drive. Now, what's fascinating here is that the battery is under a two-pronged attack. You've got the high-frequency rattling and shaking from driving over rough construction sites, but on top of that, you have this constant, low-frequency, heavy wobble from tons of wet concrete sloshing around in the drum. It's this dual threat that creates a chaotic vibration pattern that would literally tear a normal battery pack to pieces. So how on earth do you engineer something to survive that? With a really elegant three-step strategy. First, you simulate that unique vibration combo, the random road noise plus the rhythmic concrete slosh, to predict exactly where the stress points are going to be. Second, you isolate the entire battery box from the truck's twisting frame using these really cool specialized mounts. And third, you absorb the vibrations inside the pack itself, using flexible internal connectors that can bend and move for years without breaking. Okay, so the engineers figured out how to stop the battery from shaking itself apart. Problem solved, right? Well, not even close. Now they face an even bigger challenge, a masterclass in safety and red tape, trying to navigate conflicting international rules to make sure this thing can be sold everywhere. And this is a huge change in thinking about battery safety. You see, the old rules were mostly about giving you a few minutes to get away if a fire started. The new standards, especially the ones coming in 2025, are all about making sure a fire never, ever starts in the first place. It's a total prevention mindset. This table shows you what that looks like in the real world. China has the world's toughest standard. If one single cell fails, the whole pack absolutely cannot catch fire or explode for a full 2 hours. That basically forces you to use super safe battery chemistry and things like aerospace-grade insulation. Europe, on the other hand, demands a 5-minute warning before anything bad happens, which means you need predictive sensors and smart algorithms. And then the US has its own unique crash safety and vibration rules for heavy trucks, demanding a much tougher frame. A single battery has to meet all of these different demands at the same time. So to meet that strict no-fire rule, the choice of what the battery is actually made of becomes absolutely critical. While some batteries, like NCM, can pack in more energy, LFP chemistry is just way more stable when it gets hot. You can see its thermal stability is a full 5 stars. For this kind of job, its safety and incredible lifespan make it the only real choice. And speaking of lifespan, this number says it all. At least 4,000. That's how many times you can fully charge and discharge this battery before its capacity drops. For a commercial truck that's getting used hard every single day for 8 to 10 years, anything less than that just wouldn't make business sense. The final piece of this safety puzzle is all about managing heat. There's a sophisticated liquid cooling system that makes sure the temperature difference between any two cells is never more than a tiny 5 degrees Celsius. This stops dangerous hotspots from ever forming. And if the absolute worst-case scenario were to happen, there's a specially designed vent to safely release any gas away from the driver and the rest of the truck. So we've gone through this whole incredible engineering saga, surviving the shake, passing the global safety gauntlet. But what does all this complex work actually mean for us in the real world? Let's talk about the payoff. Well, the impact is actually huge. You get silent engine-off operation at construction sites, which is a massive win for quieter cities. You get lower fuel bills for businesses and fewer CO2 emissions for everyone. You even get more precise digital control over the concrete mix itself. And maybe the biggest deal of all, you get a technical blueprint that can be used to electrify all kinds of other heavy, shaky machinery. And that really leads to the big final thought here. This whole project isn't just about one cement mixer. It's proof that even the toughest, dirtiest, loudest machines we have can be engineered to be smarter, cleaner, and quieter. So the real question it leaves us with is, what could our cities actually look and sound like if we started applying this kind of thinking everywhere?